Python decorators are a powerful tool that can enhance your code. Decorators modify the behavior of functions. This might sound complex, but it's a simple concept in practice. Decorators help you write cleaner, more efficient code. Imagine you have a function that performs a specific task, like sending an email. Now you want to add some extra functionality to that function, like logging the time it took to execute. Instead of modifying the original function, you can use a decorator. Think of a decorator as a wrapper around your function. It takes your function as input, adds some extra code, and returns the modified function. This way, you can add functionality without directly changing the original function's code. Let's dive deeper into the wrapper analogy and understand how it applies to decorators in programming. Visualize a gift wrapped beautifully for a special occasion. The wrapping adds an element of surprise and delight. The gift itself remains unchanged, but the wrapping enhances its presentation, making it more appealing and exciting. Similarly, a decorator wraps around a function, adding additional functionality without altering the core purpose of the function. The core functionality of the function remains the same, but the decorator adds an extra layer of behavior, enhancing its capabilities. In Python, functions are first-class objects, meaning they can be passed as arguments to other functions and returned as values. This allows for a high degree of flexibility. This flexibility is crucial for understanding decorators, as it allows functions to be manipulated and extended in powerful ways. A decorator is essentially a function that takes another function as input and returns a modified version of that function, often enhancing or extending its behavior. In this example, the decorator function is designed to add new functionality to the original function. It takes a function as input and defines a nested function within its scope. The nested function executes the original function within its own body, allowing you to add code before and after the original function call, thus modifying its behavior seamlessly. Decorators serve a crucial purpose in Python. They enhance code readability, reusability, and maintainability. They allow you to modify the behavior of a function or class method in a clean and readable way. Decorators promote the dry, don't repeat yourself principle by encapsulating common functionality. This means you can avoid writing the same code over and over again. Consider the scenario of logging function calls in your application. Without decorators, you might add logging statements within each function you want to track. This can quickly become cumbersome and error-prone. This approach leads to code duplication and makes it harder to maintain consistency. Every time you need to update the logging logic, you have to do it in multiple places. Decorators offer an elegant solution. By defining a logging decorator, you can apply it to multiple functions without cluttering their core logic. This keeps your code base clean and organized. This enhances code readability and makes it easier to update the logging mechanism in one place. If you need to change how logging works, you only need to update the decorator. Moreover, decorators promote code reusability. Once you define a decorator, you can apply it to various functions throughout your code base. This makes your code more modular and easier to manage. This saves time and effort, as you don't have to rewrite the same code repeatedly. In the long run, decorators can significantly reduce the amount of code you need to write and maintain. Python provides a convenient syntax for applying decorators using the symbol, known as the pi syntax. This syntactic sugar simplifies the process of decorating functions. Imagine you have a decorator named and a function called. To apply the decorator, you simply place it above the function definition, preceded by the symbol. The syntax is equivalent to. This syntax makes the code more readable and intuitive. It clearly indicates that the function is being decorated by the decorator. Section 5. Decorators in action. A logging example. Let's illustrate the use of decorators with a practical logging example. Suppose you want to log the name of every function that gets executed in your application. Python def log. Return result return wrapper at log underscore function underscore call def greet name. Print fellow name greet Alice. In this example, the decorator takes a function as input and returns a wrapper function. The wrapper function logs the function name before and after executing the original function. When is called, the output will be calling function greet hello Alice, finished calling function greet. This demonstrates how the decorator seamlessly adds logging functionality without modifying the function's code. Section 6. Practical use cases of decorators. Decorators have numerous practical applications in Python programming, making them an essential tool for developers. They excel in scenarios where you need to add common functionality to multiple functions without code repetition, streamlining your code base. Decorators are particularly valuable for implementing authentication and authorization checks, which are critical for security. For instance, you can define a decorator that verifies user credentials before executing a protected function, ensuring secure access. This ensures that only authorized users can access sensitive operations, safeguarding your application. Measuring the execution time of functions is crucial for performance optimization, helping to identify slow code. Decorators provide an elegant solution for timing functions and identifying potential bottlenecks, improving efficiency. Data validation is essential for maintaining data integrity, ensuring that your application runs smoothly. Decorators can enforce input validation rules, ensuring that functions receive valid data, which is crucial for reliability. This prevents unexpected errors and enhances code reliability, making your application more robust. These are just a few examples of how decorators enhance code clarity, maintainability, and reusability in various programming tasks, making them indispensable for modern development. Section 7. Reusability, a key advantage of decorators. One of the most significant advantages of decorators is their reusability. Once you define a decorator, you can apply it to multiple functions across your project, promoting code consistency and reducing redundancy. Imagine you have a set of functions that interact with a database. You can create a decorator to handle database connections and transactions, ensuring that these operations are performed consistently across different functions. Python def DB transaction func, media, programmer writing Python code, developer working with database, code editor with Python scripts, def wrapper, quargs, result equals sign func quargs, connection.com, MIT. By applying the decorator to relevant functions, you centralize database connection management, improving code readability and maintainability. Section 8. Combining multiple decorators. Python allows you to stack multiple decorators on a single function, creating a chain of functionalities. This enables you to compose complex behaviors by combining simpler decorators. Consider a scenario where you want to log function calls, measure their execution time, and cache their results. You can achieve this by applying multiple decorators in the desired order. At cache _result at log _function _call at time _execution def fetch data URL. Media screen showing Python code with multiple decorators, programmer typing code with decorators on a laptop. In this example, the function is decorated by 3 decorators, and the decorators are applied from bottom to top. First, measures the execution time, then logs the function call, and finally, caches the result. Section 9. Decorators enhancing code. Clarity and structure. Decorators contribute significantly to code clarity and structure by separating concerns and promoting modularity. They allow you to extract cross-cutting concerns, such as logging, authentication, and caching, into reusable decorators. By applying decorators, you keep the core logic of your functions concise and focused on their primary purpose. This separation of concerns enhances code readability and makes it easier to understand the flow of execution. Furthermore, decorators promote code reuse and maintainability. If you need to modify a cross-cutting concern, you only need to update the corresponding decorator. The changes will be reflected in all functions decorated by it, without the need to modify each function individually. Section 10. Conclusion. Embracing the power of decorators. Python decorators are a powerful tool that empower you to write cleaner, more maintainable code. They enhance code reusability, readability, and modularity by enabling you to modify the behavior of functions without directly altering their code. From logging and authentication to performance monitoring and input validation, decorators offer elegant solutions for various programming challenges. By embracing decorators, you can elevate your Python programming skills and create more efficient and maintainable applications. Section 11. Call to action. Explore and experiment. As you delve deeper into the world of Python, I encourage you to explore and experiment with decorators. Try implementing decorators for different use cases, and discover how they can simplify your code and improve its structure. Remember, mastering decorators takes time and practice. Start with simple examples, gradually increasing the complexity as you gain confidence. The more you experiment, the more you'll appreciate the elegance and power of Python decorators.